Assalamu alaikum. My dear viewers, have you ever wondered how the electromagnetic radiation, or EMR, interacts with our atmosphere and the Earth's surface? This question is likely to have crossed the minds of many who find themselves captivated by the sparkling celestial bodies above, or those who cherish basking in the warmth of the sun's rays. Today provides us with an exceptional opportunity to unravel the mysteries of this cosmic phenomenon. Our journey begins with understanding the fundamentals. What is electromagnetic radiation, we may ask? In the most basic terms, electromagnetic radiation can be described as energy in transit. This energy is propagated or radiated across space or through a material medium in waveform. These waves, aptly named electromagnetic waves, possess both electric and magnetic components. Remarkably, they travel at the speed of light, a staggering rate of roughly 300 kilometers per second. But where does this EMR come from? The response is as vast as it is simple, everywhere. The universe, in all its infinite expanses, serves an active, dynamic stage for the ceaseless performance of electromagnetic radiation. From the glimmering stars that pepper our night sky, to the mundane appliance you use to warm up your evening meal, EMR is a constant presence. It is emitted by atomic and molecular particles, making it a fundamental part of the physical world as we perceive it. But EMR is not a simplistic one-dimensional concept. It exists in a myriad of forms, each as fascinating as the next. These diverse forms come together to form the electromagnetic spectrum. This spectrum spans a vast range of both wavelengths and frequencies, from the exceedingly short waves of gamma rays to relatively longer waves of radio signals. Why then should we pay attention to EMR? Its importance is far greater than one might initially presume. It shapes our daily experiences in ways we often take for granted. From the visible light that allows us to marvel at a spectacular sunset, to the ultraviolet rays that skin absorbs to manufacture vital vitamin D, or even the comforting warmth of infrared waves, EMR is intimately entwined with our existence. We have now gained a basic understanding of electromagnetic radiation. We can now dive into the intricate relationship between EMR and the Earth's atmosphere and surface. Are you ready? Buckle up, because this journey is bound to be electrifying. Our atmosphere, an invisible blanket, does more than just provide us with the air we breathe. It's a swirling, vibrant cocktail of gases, primarily nitrogen and oxygen, with a dash of argon, carbon dioxide, and a diverse array of other trace elements. It's a dynamic blend, always shifting, always moving, unseen yet omnipresent. Yet there's so much more to this gaseous envelope than meets the eye. So many roles it plays, so many functions it serves. As a crucial component of our planet, the atmosphere is our primary line of defense against the relentless barrage of electromagnetic radiation, or EMR, that the sun ceaselessly hurls our way day in and day out. Now let's clear up a misunderstanding. Not all forms, not all types of EMR are harmful. In fact, without it, life as we know it wouldn't exist. The sun emits a wide, diverse range of EMR, from the visible light that allows us to see our world in all its vibrant colors, to the infrared radiation that keeps our planet comfortably warm. However, within this broad spectrum, this wide range of radiation, there are certain types we'd rather avoid, given the choice, like the dangerous ultraviolet rays, the potent X-rays, and the extremely powerful gamma rays. This is where our atmosphere, this gaseous shield, steps in, playing a crucial role. Acting like a cosmic sieve, a celestial filter, our atmosphere absorbs and scatters these potentially harmful, damaging types of EMR. The ozone in the stratosphere, for instance, absorbs most of the sun's ultraviolet radiation, preventing it from reaching the surface and causing harm to life forms. Despite its protective nature, our atmosphere doesn't stop all EMR. It allows visible light, certain ultraviolet rays, and a portion of infrared radiation to pass through. This is a good thing, a beneficial aspect. These types of EMR are absolutely indispensable for life as we know it. They gift us with daylight, aid plants in photosynthesis, and provide the warmth we need to survive and thrive. So while the atmosphere may seem like an invisible, intangible entity, it's actively, constantly working to shield us, protect us every second of every day. It's a delicate balance, a fine line to walk. Too much absorption and we'd be in the cold, too little and we'd be fried. Clearly, our atmosphere plays a crucial role in determining which EMRs reach the Earth's surface. But what happens when they do? Well, that's a tale for another scene. Stay tuned to unravel this fascinating cosmic story. When EMR finally reaches the Earth's surface, the interaction is akin to a dramatic dance. Picture a grand ballroom where photons, the infinitesimal packets of energy that make up EMR, engage in a three-part waltz with the Earth's surface. The dance's steps: absorption, reflection, and transmission. Let's begin with absorption. As photons touch down on the Earth's surface, they're often absorbed by the materials they encounter. This absorption heats the surface, which in turn releases the energy back into the atmosphere as heat. This process, known as thermal radiation, is responsible for our planet's temperate climate and is integral to the water cycle, driving evaporation and hence cloud formation. Now, imagine a photon getting ready to take a spin on the dance floor, but instead of being absorbed, it's sent right back where it came from. This is reflection. Different surfaces have different reflectivity. For instance, a smooth, white surface like snow reflects a lot of sunlight, while a dark, rough surface, such as a forest, absorbs more. This phenomenon is known as albedo, and it plays a pivotal role in regulating Earth's temperature. Lastly, we have transmission. Some photons don't get absorbed or reflected, but instead pass straight through, like sunlight through a pane of glass. This happens with certain materials like water and glass, and it's the reason we can see light through these substances. These interactions, absorption, reflection, and transmission, are not independent of each other. They are interconnected and work in harmony to influence our climate and weather. They determine the amount of sunlight that reaches us, the warmth of our days, and the chill of our nights. The dance of EMR with the Earth's surface is an intricate ballet that shapes our world in ways we often take for granted. The complex interplay between EMR and the Earth's surface has profound impacts on our world. But what does this mean for us? Stay tuned as we delve deeper into this dance and its significance in our everyday lives. The dance between EMR, our atmosphere, and the Earth's surface isn't just a spectacle of nature. It directly impacts our lives. The interplay of these forces is woven into the fabric of our daily existence and holds profound implications for our future. Let's consider weather forecasting, for instance. The remote sensing technology used in satellites is fundamentally based on the principles of EMR interaction. These satellites detect and measure EMR, reflected or emitted by the Earth's surface and atmosphere. The data gathered provides us with vital information about weather patterns, enabling meteorologists to predict storms, hurricanes, and other weather events with remarkable accuracy. This information is crucial, not just for planning our weekend picnics, but for safeguarding lives and property in the face of severe weather conditions. Then there's the issue of climate change. Changes in the Earth's climate are closely linked to variations in the amount of solar radiation, a form of EMR, absorbed and reflected by our planet. Understanding how EMR interacts with the Earth's surface and atmosphere allows scientists to better model climate change and predict its future impacts. This knowledge is at the forefront of our efforts to mitigate the effects of global warming and preserve our planet for future generations. But the implications of EMR interactions extend beyond the environment. They are integral to the functioning of our technologies. From the GPS systems that guide us on our journeys, to the satellite communication networks that keep us connected, to the medical imaging tools that help diagnose and treat diseases, these are all based on EMR. Without a deep understanding of how EMR interacts with matter, these technologies would simply not exist. In conclusion, EMR interactions are not just fascinating scientific phenomena, they are vital to our survival and prosperity. They shape our understanding of the world and enable the technologies that drive our modern lives. The way EMR interacts with our world is a testament to the intricate and delicate balance of nature. Today, we've embarked on a journey from the far reaches of the cosmos to the ground beneath our feet. We've explored the enigmatic world of electromagnetic radiation, a form of energy that travels through space and time, touching every aspect of our lives. We've discussed the atmosphere, our planet's protective shield, and how it interacts with these energy waves, affecting their behavior and ultimately their impact on the Earth's surface. We've dived into the intriguing relationship between EMR and the Earth's surface, showcasing how this interaction shapes our environment and influences the conditions for life. Moreover, we've highlighted the profound impact of these interactions on human life, from the technology we use daily to the health implications we face. As we move forward, understanding these interactions will be key to solving many of the challenges we face. The dance of EMR continues, and we are all part of it. Thanks for watching. Subscribe to Quest.